Namaskar, I am Dan Gowde, Assistant Professor in Mathematics, Center for Distance Education, Shivaji University, Kolhapur. Find the extremal. I will discuss the problems on isometric parametric problems related to the variational principle. In last lecture, we studied the maximum area enclosed by the circular area arc, circular curve. Problems. There are examples. Find the extremal for an isoperimetric problem. I of x is equal to integral from 0 to 1 y dash square plus x square dx, subject to the condition that 0 to 1 integral from y square dx is equal to 2 and y of 0 is equal to 0, y of 1 is equal to 0. Solution. The functional which is to be extremized is given by y of x is equal to integral from 0 to 1 y dash square plus x square dx, such that integral from 0 to 1 y square dx is equal to 0 2 and y of 0 is equal to 0, y of 1 is equal to 0. Thus the extremization of 1 under 2, we know that the condition that is satisfied by del by f star by del by y minus del by f star, d by dx of del by f star by del by y dash is equal to 0, where f star is equal to f plus lambda g. Therefore f star is equal to y dot square plus x square plus lambda y square, where lambda is a Lagrange's multipliers. Solving and this d by dx del by f by del by y dash minus del by y minus d by dx of del by y dot del by f by del by f y dot is equal to 0, and we get y triple dash y double dash minus lambda y is equal to 0. This equation has roots d square minus lambda is equal to 0, d is equal to plus d square is equal to lambda and d is equal to plus minus lambda, and this way this y is equal to plus minus lambda for square root of lambda. For lambda greater than 0, there arises three cases. For lambda is equal greater than 0, or lambda is equal to plus minus I lambda square root of lambda, for lambda greater than 0. Okay, suppose if the lambda greater than 0, then the solution of the equations y double dash minus lambda y is equal to 0 is y is equal to e raised to square root of lambda x plus b raised to e raised to minus lambda square root of lambda x. Conditions that y of 0 is equal to 0, therefore a plus b is equal to 0, y of 1 is equal to 0, therefore a e raised to square root of b lambda plus b e raised to square root of minus square root of lambda, and solve for a and b. So solving for a and b, we get b is not equal to 0, therefore e raised to 2 lambda square root of lambda is equal to 1, therefore e raised to 2n pi, therefore 2 square root of lambda plus 2i n pi e raised to 1 is equal to e raised to 0, therefore is equal to 0, therefore square root of lambda is equal to minus I n pi, minus I n pi. This is contradictory to lambda is positive, hence b is equal to 0, and consequently a is equal to 0, proving this equation has only trivial solution. Case second, let lambda less than 0, the solution of the equation 6 y is equal to b for imaginary roots If complex root, then a is equal to cos of square root of lambda x plus b sine of square root of lambda x. Boundary condition 3 gives y of 0 is equal to 0, therefore a is equal to 0, y of 1 is equal to 0, therefore b sine of square root of lambda x is equal to 0. Therefore, square root of lambda is equal to n pi for lambda is not equal to 0. Hence, the required solution becomes y is equal to b sine of n pi x, and therefore b is equal to plus minus 2, and hence y is equal to plus minus 2 sine n pi x. This is required condition. Next example, find the extremal for an isoperimetric problem. I of y of x is equal to integral from 0 to pi y dash square minus y square dx, subject to the condition that the integral from 0 to pi y dx is equal to 1, y of 0 is equal to 0, y of pi is equal to 1. In this, it is given that y of x is equal to integral from 0 to pi y double dash square minus y square dx, where the functional I is to be extremized under the conditions integral from 0 to pi y dx is equal to 1, therefore, and y of 0 is equal to 0, y of pi is equal to 1. The corresponding Lagrange equation is del by f star by del by y minus d by dx of del by f star by del by y dot is equal to 0, where f star is equal to f plus lambda g. Therefore, f star is equal to y dash square minus y square plus lambda y. Hence, the equation 4 becomes by double dot minus plus by is equal to lambda by 2. Therefore, complementary function is given by y is equal to a cos x plus b sin x, and a particular solution is given by y is equal to lambda by 2. Therefore, general solution is y is equal to a cos x plus b sin x plus lambda by 2. To determine the arbitrary constant of integration, we use the boundary condition that y of 0 is equal to 0. Therefore, a is equal to minus lambda by 2. Y of pi by 2 is pi is equal to 1, y lambda is equal to 1, a is equal to minus 1 by 2. To determine other constant of integration, we use integral from 0 to pi y dx is equal to 1. That is minus 1 by 2, 0 integral from 0 to pi cos x dx plus b integral from 0 to pi sin x dx plus 1 by 2 integral from 0 to pi dx is equal to 1. This gives the value of b as b is equal to 2 minus 5 divided by 4. Hence, the required curve is y is equal to 1 by 2 into 1 minus cos x plus 1 by 4 into 2 minus pi sin x. And this is solutions, required solutions, and we get